Hi everybody, Dr. White here with the little R exercise I promised where we learn how to simulate a random variable from the uniform distribution. So we're going to follow up with the example we were talking about on paper in the previous screencast. I got a script written up around that, so head to the common folder here and see if I can pick it up. Dr. White stuff, Math 331, scripts, and sure enough, there's a Ch05-1. So in this the situation we were in, we had a random variable x that had a PDF that looked like 3/2 x squared, between -1 and 1. And we went and found its CDF, and it was that, x cubed plus 1 over 2 from -1 to 1. And we went and found the inverse of that CDF function, and it was 2x minus 1 cube rooted, raised to the 1/3 power. And that would be for values from 0 to 1, the inverse of a distribution, so that the possible y values are 0 to 1. So those become the domain of the inverse. So the procedure that we learned the theory of in section 5.1, it seems easy enough to implement. We just got to grab a lot of random uniform values with lower limit 0 and upper limit 1. So here I am, I'm just going to grab 10,000 of them and call it unifs. So there's unifs in the global environment. And so our simulations would be F inverse of the unifs. So this is kind of cool. R does vector arithmetic kind of like all at once. 2 times unifs would multiply everything in unifs by 2. Subtract 1 would subtract 1 from everything in that. And then raised to the 1/3 is going to cube root every one of those things. So off goes sims. All right. And you may notice in the global environment there might be something up. I see some like NaN sometime. NaN stands for not a number. Let me just sort of blow by that right now and make my data frame, whose only column is those sims, and that column is called X. I'll go ahead and make sure I've got ggplot2 loaded. Okay, I've loaded it. And let's make a density plot. So ggplot, I guess I could just say df, huh? The data frame I've already made. And I won't make a rug. I'll just go ahead and do this. And so like I get this kind of weird plot. I'm going to take my face away. It's only plotting for x's like between 0 and 1. It seems to be like leaving out negative x's. But, if this was a correct simulation, then the density plot ought to look like the PDF. It ought to look like 3/2 x squared, x going from -1 to 1. So there ought to be like another hump thing exactly symmetric to this kind of on the other side extending back to -1, and there's not. And those NaNs, they're really starting to bother me now. You'll notice there's a little warning message that it removed basically about half of the values from the plotting attempt. And it's because they were NaNs. They weren't numbers and couldn't do anything with them. So we really need to look into that. So what's going on here? So let me make just another data frame with 2 columns in it. My unifs that I've already made and those sims. Okay, call it test df, and let's pop it up. And so what I'm noticing is that when the unif is kind of big, kind of close to 1, twice it minus 1 cube rooted is defined. But when the unif is kind of small, twice it minus 1 cube rooted is not defined. Like this one here, 0.13. Let me see. Let's go down here and do 2 times that. Let me see. Can I copy this? Command C, copy. Okay, now paste that in. Now do a -1, and then let's raise to the 1/3 power, and it's NaN. Yeah, so no surprise. Okay, let's try something like, what about like -8? Let's take the cube root of it, all right? We know the cube root of -8 is -2. And by golly, they say it's not a number. So R's got a funny quirk. When it raises stuff to powers, I think it just is assuming that it's raising a positive base to the power, and it just NaNs you otherwise. So we're going to have to find a workaround for that. Okay. So let's head back and think about it. Here's my idea for a workaround. There is an R function called sine. And what it does is it takes a negative number and returns -1, and a positive number and returns 1. So like sine of -5, check it out in the console, -1. Sine of 5 is 1. Now another function that's in R is absolute value, ABS. Absolute value of 5 is itself, 5. Absolute value of -5 is 5. I can use absolute value and sine together to get it right. I'm making a new data frame here in this command, which has only one column called x. And what it is this. I look at twice unifs -1, and I take sine of it. And so that's going to give me a bunch of ones and -1s. It's going to give me a 1 whenever twice unifs -1 is a positive number, a -1 otherwise. And over here, I'm taking the absolute value of twice unifs -1. So that'll always be a positive number because absolute value. And I raise it to the 1/3. But since I'm multiplying here by that sign, something that should have come out as a negative cube root is going to come out that way. And if this here was positive, then this sign is going to be a 1, and I'll leave it alone. So this is going to give me my correct cube roots, whether my base was a positive or a negative number. Okay, so let that be my data frame, calling it df there. And let's stick that into a ggplot function and see what happens. And now it's looking much better. So the x's are ranging from -1 to 1. And we're getting that kind of parabolic shape, that 3/2 times x squared shape. It's dropping off a little bit on the edges, and that's just a function of like what kind of values it finds and the decision it makes about what to do on the endpoints to estimate the density function. I think we'll get a little bit better behavior if we went up and did like maybe a larger number, like maybe 100,000. Okay, and so let's do the unifs there. And then we could head back down and we could make this data frame again. And so now it's got 100,000 rows. And now with 100,000 observations, let's see if it does any better. Yeah, it's kind of like it's squeezing those humps closer and closer to the -1 and the 1. And if I could do this for like infinitely many random uniforms, I think I'd see my perfect parabolic shape. So that's the simulation working after a bit of a workaround on the quirky arithmetic that R gave us there for powers. See you later.